Development-oriented agile practices affect the way we develop software, that is to say, in particular, how we design it and how we implement it. Most of these techniques actually come from XP, extreme programming, because of all the agile methods. This is the one that is the most software specific, less focused on management, and particularly focused on development. The best known and most controversial of these techniques is pair programming. It's controversial because Ken Beck, the originator of extreme programming, told everyone, in particular in his books on extreme programming, that this is the way everyone should develop software, always in pairs. Well, in fact, very few teams do this all the time. However, pair programming remains an interesting technique to be applied occasionally. So what's the idea? Well, pair programming means that you have two people developing software together. So instead of having one programmer, you have two writing a single piece of code. They are sitting together at one machine. One of them, of course, at any time has the keyboard and mouse, but they could change. And they think out loud. So they are not going to enter anything into the editor before explaining what the person at the keyboard is planning to enter, or if it's the other person taking the lead, what he or she suggests entering. So everything is discussed and everything is explicit, and that's one of the main advantages advocated for this process. Instead of keeping everything for yourself in your head and sometimes a bit vague, in particular the rationale for what you're doing, you make it explicit, and often, and that's one of the immediate advantages, just trying to explain your way of thinking, your rationale to someone else means that you're going to realize that you cannot express it, or you can find an inconsistency or a contradiction right away, and so you'll be stopped in your tracks, and this will be a bug that does not happen. Another advantage, of course, is that the two partners can keep each other on task. At least that's the idea. They are not going to start talking about their latest vacation, but they they keep each other focused on the programming task at hand. They can brainstorm together. They can clarify their ideas. What happens also in software development, of course, is that once in a while you get stuck. Well, there's a chance that not both of them will get stuck at the same time. So when one is stuck, the other can take the initiative. And of course, in a team that has practices, best practices, the methods guidelines or the company guidelines or the project style rules, then they can hold each other accountable and kill any attempt to deviate from or violate the rules. And this is actually a very good technique. What is really not desirable is to impose it as the sole technique for developing software, as the most extreme of the extreme programmers would have us do. It turns out that it's one of the agile techniques for which we can test the effects on productivity and quality, because of course on the one hand you have standard classical managers, maybe the MBA types, who say, well, this is going to decrease productivity because for the same number of programmers you're going to have twice as few programs being developed. And then you have the XP advocates which say, well, any of this is going to be more than compensated by all the bugs that we have avoided by finding them before they even have had a chance of becoming bugs, simply bad ideas that are discarded right at the root. So we can test that, and it's one of the areas that has been the most thoroughly studied in experimental studies of agile programming. So you take two groups of programmers, one using pair programming, the other not using it, using, for example, more traditional quality techniques such as code reviews, code inspections, and you look at the results. And these results, as confirmed by many studies, do not show any major advantage one way or the other. It turns out that pair programming has about the same results in productivity and quality than more traditional quality-oriented techniques like code reviews. It doesn't mean that pair programming is a bad idea. In fact, it's a very good idea, especially for tricky cases, and this has become part of the modern battery of tools of the programmer as one of the tools. Of course, it's a mistake to impose it as the only tool, but for delicate cases, it's quite natural for programmers to want to study and implement a particular piece of the project in collaboration with someone else. One mistake that is sometimes made in practice is to confuse pair programming with mentoring. That is, to pair a senior person with a more junior person with a hope that it's going to give the advantages of pair programming as well as help train the junior person. Well, mentoring is a good technique, but it's different from pair programming, and you cannot do the same, the two together and expect the same results. So you can do mentoring, you can do pair programming, but for strict pair programming, the two members of the pair should be of approximately equal levels of competence. Another agile technique, specifically extreme programming, is the idea of a single code base. And there's a strong emphasis, and I would say quite justified emphasis, in the XP community against branching. Branching, which is in principle easy, you start developing two parallel versions of the software, causes lots of problem because at some point you have to reconcile these branches, and a rather simple view that you should have just one branch is quite healthy. Another XP emphasis is on shared code. Agile methods reject code ownership, that is to say, the situation in which one person is responsible for a particular part of the code and is the only one, or a small group is the only one permitted to change a certain part of the code. Now, we're not talking here about intellectual property. This is another matter. We're talking about permission to change. And in many companies, some parts of the software are the exclusive province of someone or a group of people. And in agile methods, particularly in XP, the idea is that this should not be the case, and that anyone in the project should be permitted to modify anything. This is more debatable. Of course, the arguments are clear. Code ownership creates necessary dependencies between team members and creates delays. It also gives the opportunity for blame game, because my stuff is not working, but it's not my fault. I can do nothing about it. I depend on my colleagues' code, which I cannot change. So all this is good. On the other hand, it's also true that you need some discipline in a software project, and that sometimes some people are much more competent than others at modifying delicate parts of the code. So this is a piece of advice which is good for reflection, but it should be applied with caution. Another standard extreme programming piece of advice, which of course is not new with XP, is to leave optimization until last. Wait until you have finished the user story and run all your tests before you try to optimize your work. This is usually good advice, but of course sometimes optimization cannot be completely done afterwards, especially big optimization having to do with algorithm complexity and the choice of the right algorithms. Continuing with design, there's this idea that we have already seen of simple design in agile methods in general, and XP in particular. Produce the simple design that works. Remember that slogan, the simplest thing that could possibly work. And then refactor. Refactor means improve the design afterwards, and we're going to come back to refactor in just a minute. It's not only simple design, but it's incremental design. Now, you might think that you're practicing incremental design even if you're not using extreme programming, but here it goes further than the basic idea of doing things one at a time, which is rather straightforward. Here, incremental design, as seen in extreme programming, really means don't abstract right away. Look at individual cases and solve these individual cases, as explained in some detail in this article by Shore here. Start by creating the simplest thing that could possibly work, then incrementally add to it as the needs evolve, rather than looking for abstractions. And this article actually criticizes politely the usual practice of abstracting first. It recognizes, it admits that the ability to think in abstractions is often a sign of a good programmer. Yes, and that is definitely true, but still, this article argues against it, XP argues against it by saying don't try to be all things to all people. This is also part of the general push against too much a priori reuse and too much a priori design for extension, for extendability. Well, just do what you are asked to do. And then generalize. Well, as often there's a mix of good and bad here. It's true that sometimes it's better to solve the problem at hand, but it's also a mark of the good engineer that he or she designs not just for the problem of the moment, but for future extensions, and abstractions indeed are signs of good programmers. So this is kind of the more Luddite aspect of extreme programming to be viewed with caution. Now, when we look for abstractions, one technique that some extreme programming literature recommends is the system metaphor. Now, this has somehow gone out of fashion, so I'm not going to go into it in detail. I'll just mention the idea. How do you actually abstract right? Well, one of the elements of advice here is the system metaphor, which is meant to be agreed upon by members of the project to explain the purpose of the project and guide the structure of the architecture. So as example from that same paper by Tomejko, let's assume we have a wrist camera and then a metaphor that could help drive the project is to consider this wrist camera as cities and towns, or a variable transparency window. Well, we think of a chameleon if the window uses variable opaqueness to vary according to sensor reading. Well, I'll leave it to you to decide how useful that is, but it's important to mention it. More important and much more widely used and influential is the notion of refactoring, which was largely developed in a book by Martin Fowler. Again, the reference is in the bibliography. And the idea of refactoring is that when you have something that works, when you have a design that you have implemented and that satisfactorily addresses the user stories that you have or the tests that you have, you shouldn't stop there, because it may be good enough for the moment, but it may not be good enough for the long term. So this is where abstraction comes back, and in particular where the distrust of extendability and reusability stops, because we do want to have good designs in the end, not just designs that work, but designs that will stand the test of time. So the idea of refactoring is that once you have something that works, you sit back and take a look at how good it is from the viewpoint of design. And then you apply refactoring techniques from a catalog published in particular by Fowler. There are other additions to this catalog, of course, from later on. So examples are to encapsulate a field or an attribute into a function, to replace a conditional with a more object-oriented technique of polymorphism and dynamic binding, to extract a routine or method from some code, to abstract it into a routine if that code is important or if it's used several times, to remove a duplication, to rename, give a better name to a routine or an attribute, to move it to another class, to move it up or down in the inheritance hierarchy. This is, of course, a very good idea. In Agile methods, it's widely used as a substitute for upfront design. We have seen the rejection of upfront tasks, in particular upfront design, so the mantra goes that you don't need to do upfront design, you should just do the simplest thing that works and then refactor. And of course, this is completely wrong. The idea that you can take anything and turn it into a good design is absurd. Junk in, junk out, or garbage in, garbage out. Now, the refactoring is best applied to good designs, good but not perfect designs. And so here, as in other cases like pair programming, for example, we have a case of an agile technique which is often presented in the extreme form as a replacement for well-established software engineering techniques, and is much better applied as a complement to them. And in fact, refactoring in this specific case works best with good, but of course not perfect, upfront design. What we've seen in this segment is a number of practices that have exerted significant influence on the way we develop software, in particular two of them, pair programming, the first one, and refactoring, the last one. And it's important to note that they're extremely interesting ideas, but are best viewed as complements to, not replacements for, more upfront style techniques which we have learned to apply and perfect over 4 decades of history of software engineering.